All right, Programming 12, we're back for PVectors. Yes, I'm excited to do PVectors with you. Why? Why are we doing PVectors? That's actually a really important question, and I wanted to address it. And I think we've talked about this in Programming 11, but just to be really clear, we could do all of this with our current way of storing coordinates and velocities and eventually accelerations. With just our floats, we would be fine. But we would have to do a lot of extra work. We have to do some trigonometry, and I love trigonometry. Don't get me wrong. Trigonometry is fantastic, but but this is just easier. P vectors just make everything easier, and I think they're worth learning. I really do think they're worth learning. And in future projects, I think we're going to switch over to using P vectors because it's just going to make things easier to use. And it's cool because it's an object, and we're talking about object-oriented programming. P-vectors are objects. So let's do it. Let's jump in. So first of all, why? Here's something that we can't easily do right now. We'd need trigonometry and a bunch of stuff. Here's our movers. They're moving. They're chugging along. Maybe I want to change up the randomness, right? Like maybe I want to get real random with it. Oh gosh, that's that's too random. There has to still be a number, Mr. Peltier. I don't know how to run things. Here we go. Yeah, whoa. These are really fast. But notice that some are not. This little guy down here, it's chugging along, is slow. These ones are fast. This is fine, but what if I wanted to make everything move the same speed, but have a random direction? Like I want them all going equally fast, just in all sorts of different directions. Well, that's, Vx and Vy make that difficult because when I randomize Vx and Vy, I'm also changing their direction, not just their speed. So that's like one of the number one awesome things about p-vectors is that they allow you to separate the speed and the direction into two separate entities. And that's, I think, if no other reason, that would be enough for us. They will also allow us, because since they separate that kind of speed and direction, they'll also let us kind of look at things like speed, like how fast is this thing moving as in a two-dimensional space. Not just how fast are we moving the x and the y as a rise and a run, but ask questions like, what is the velocity? This combined, combination of these two quantities. What is that velocity? And also, what is the angle at which it's moving at? So these are all good, useful things that we'll want to know for the future. Possibly because we're going to make, laser beams and bullets and cool things jumping out of our characters that we need to know these things for. So let's look at the mechanics of what that means if I change this. So first of all, as I make these changes, lots of things are going to break. Have courage. It's okay if things break, but make the changes with me so that you can see them and have reference to them. So first of all, I'm going to replace x and y with a p-vector. A p-vector called location. And a p-vector is kind of broken into an x component and a y component, and we can store those in one thing called a location. And yeah, it's basically what a p-vector is. It's sort of a, it's like it's an entity or an object that stores an x and a y. But it has a bunch of built-in tools that allow it to, rotate that or check its heading and all this kind of stuff. So let's go and see how I now store values. That's going to be our new kind of x and y. How do I get that information inside of a p-vector? So what I'm going to do is I'm going to say p-vector, since it's a class, location, I should say. Since it's an object, we need to use the new keyword to instantiate it. So I'm going to say location equals new p-vector. And then you could, whoa, my gosh, don't do that. You could just give it some numbers here. I'm just going to go down. You could just simply say, 0, 0. That would be how you'd set x and y to 0. Whatever number goes in here is going to be the x part of our location, and the second will be the y part of our location. So what I'm going to do is I'm just going to stick, that as much as I want my movers to start at 0, 0, I don't really. So I'm just going to copy that over to here. So now my x will be randomized, and I'll copy this to my y. All right. So these are the new kind of mechanics that we are working with and dealing with. This is how we're going to set our values for our x and y now. Okay, so now, what about velocity? Yeah, velocity, same story. We have an x and a y component, so it's a perfect fit for a p-vector. Instead of this, we'll call it velocity. Now these long words, I don't know if they're necessary. Like vel, lock. I wonder if these are, I'm a little bit like hesitant to call it location and velocity. They're very much more descriptive, but our code's gonna get longer. Maybe I'll just tune it down. Vel and lock are like really common words to use for these instead. Okay, so our velocity is going to be a new p-vector again. We basically just going to be making p-vectors for this whole unit. And I'm going to randomize it. This is going to be my x, and this will be my y. So in the constructor, I'll just put that first. But if I was to say 0, 4, like this would be absolutely fine. This would be absolutely fine way to make a p-vector. It would have a vx of 0 and a vy of 4. But I don't want that. I want a random one because I'm just, copying a previous example. So that's how you work with it. All right. Bada bing, bada boom. So, I guess you might notice that the code's a bit shorter, but don't let that make you feel like, oh man, that's the reason we're doing this. It is true. It is a bit shorter, but it's the power of things. And we'll get into that in a little bit. Let's go now see how we move things now, because it's not going to be x equals x plus vx because we don't have those things anymore. But it turns out that one thing that p-vectors let you do is just add them together. In the same sense of this code is adding the vx onto the x and the vy onto the y. P-vectors have a built-in way to do that. You can say location dot add velocity. So this basically, the add function of p-vectors adds the x component of velocity onto the x component of location. It basically does this, and it also does the y onto the y. Boom. That's it. There you go. Location.add velocity. And this is kind of cool because this is really, if you've been doing physics, sorry if you've been doing physics. No, just kidding. Physics is wonderful when it makes sense and painful when it doesn't. But, this is sort of the definition, right? A velocity is a change in position. That's the definition of velocity in your physics textbook. So now we're just changing our position with the velocity. We're just adding them. And it's all, vectors. If you did vectors in physics, with the arrows, adding them head to head, this is the exact same thing. So we're getting a little bit closer to the, scientific way of describing things, and that's also a good thing. So yeah, we can treat a location and a velocity as kind of single entities, but sometimes you don't want to. You want to just work with the x components and the y components. So the bouncing is a good example of we can still split it. We can still treat it like an x and a y. They're separate. So here's how you would do that. If I want to just see if I'm touching the side of the screen, left or the right, I can say location.x. I can just look at the x. This will access the x component of our p-vector, of our location. So I can do that. And then I want to only, oh my gosh, I got to get used to this keyboard. I'm using my son's keyboard. Don't tell him. So we want to treat just the x component of the velocity, right? So it'll just be velocity. Oh, velocity dot x. So we can still manipulate things the way we used to. It's a little bit more cumbersome instead of saying vx or saying vel.x, but we can still treat it the same. So we haven't lost anything, but we've gained some things. So that's a big deal. Okay, this is the next line. We just have to specify now that we're looking at the y components of these things. So yeah, so we can still do the old things. Let's just go finish off making the changes. I think that the other changes here, go ahead and think about this. How are we going to do this? Oh my gosh, how do we get the x out of our location and the y out of our location? Did you say lock.x and lock.y? You killed it. You did it. How about if we're looking at another mover's location? We used to just say .x. Okay, so this is a little ugly, not gonna lie. Not everything is wonderful in the world of p-vectors. It's not the best ever. But okay, it's doable. So we can say movers.location.x. It's a little ugly, but not bad. So yeah, I can look at the location of another mover with this. That's the location of my mover. What else do I gotta do? Well, I guess I have to draw my line in a similar way. So this is gonna be exactly the same as this. So I'll just copy and paste it down there. And did I miss anything? I think that's about it. I think that solves it. I don't know, there's a funny little error here. Function dist accepts parameters. I forgot to, I should have copied, not cut. Okay, yeah, there you go. So does this work? Oh, whoa. We gotta fix this one. You got this. What's it gonna be? Oh, did you say location.x? Location.y? You killed it. Better than me. Okay, so I want to just run it, make sure it works. Okay, so it's working. It's good. We've changed it over. So in the next video, I want to show you a couple of cool things you can do with PVectors. We looked at it a bit with the ad, but I've been talking for a long time. You need a break. Maybe go get a drink of water. I don't know. And then come back and we'll see some other examples of things you can do with PVectors. Thanks, everybody.